All right, let's jump right into this explainer. Today, we're unpacking the incredibly fascinating mechanics behind a model called Coder V2.5. For the longest time, the tech world has just been obsessed with parameter counts and massive data scraping. The standard operating procedure has basically been, if we just feed an AI more and more code, it's going to magically get smarter. But this research from the Quicot team takes a completely different, infrastructure-first approach, and it's literally changing the way we train artificial intelligence. Let's get into it. So, here's the big question we need to ask. Is bigger always better for AI? It's a super common assumption, right? That AI just needs massive amounts of data and larger models to improve. Well, today, we are completely shattering that myth. The true obstacle actually isn't model scale. The real bottleneck is the scarcity of reproducible environments and strictly verifiable rewards hidden inside messy, real-world code repositories. Think about it. If an AI can't reliably test and verify its own code the exact same way a human developer does, throwing a billion more parameters at it definitely won't magically solve complex software engineering problems. To really appreciate this breakthrough, we have to fundamentally contrast the old era of AI coding with the new. We are moving way, way beyond passive autocompletion, where an AI just guesses the next and tactically correct line of code. We are entering a brand new paradigm of autonomous agentic behavior. This means the AI has to understand plain English requirements, navigate through a bunch of scattered files, design a fix, run tests, and then iteratively repair its own failures. It's kind of like upgrading from a simple spell checker to a senior engineer who actually tests their own code. It requires real, long-horizon planning, not just good guessing. Let's move on to Section 1, Building the Ultimate Sandbox. Okay, so to scale up this kind of training, we have to start with the environment scaling engine. This system essentially mines tasks straight out of real pull requests and commits. But as any developer knows, raw issue descriptions are often incredibly ambiguous, incomplete, or just totally inconsistent with the final merged code. So the agent actually steps in to extract precise, executable task descriptions from all that noisy data. It basically creates a purely verifiable task, defining a crystal clear problem statement, strict requirements, and interface constraints. This ensures the model is actually training on clear, executable goals instead of confusing, real-world text. And that brings us to AutoBuilder. You can think of this like an automated pipeline where the AI acts as a construction worker building its own clean, reproducible sandbox. First, a build agent analyzes the repository and writes a custom configuration script to install all the necessary dependencies. Then, a verification agent executes this inside an isolated sandbox. And here is the crucial part. They don't just look at superficial command-exit codes to see if it worked. The system actually parses structured test framework outputs to guarantee the environment is running the intended tests reliably. Now, anyone who codes knows that setting up these environments is notoriously brittle. But the AutoBuilder pipeline completely changed the game here. By utilizing pre-configured base environments and reusable build recipes distilled from previously successful setups, this automated construction boosted the success rate from a measly 16.5% all the way up to an impressive 57.2%. And because of that massive leap, the team was able to create over 100,000 verifiable task setups across 12 different programming languages. The sheer scale of this automated sandbox is just staggering. Which leads us perfectly into Section 2, the data scaling flywheel. So here is a really important takeaway. A failed attempt is not useless. In standard training, if an AI fails a test, you just toss that data out. But Coder V2.5 specifically recognizes near misses. Imagine the AI perfectly localized a bug in a massive codebase, but maybe it just missed one decisive test assertion or a schema match. Throwing that away completely wastes all of that highly valuable search and repair behavior. Instead, what the system does is inject targeted process hints to help the AI cross the finish line on those incredibly difficult tasks. You might be wondering, how does this data flywheel actually work without, cheating? Because obviously, if you just hand the AI a hint, you can't use that as pure training data. Well, once a hint-boosted trajectory successfully finds a verified patch, the system locks that patch in and forces the model to regenerate a completely clean, hint-free trajectory from the original task context. This ensures that the final training remains entirely faithful to the real-world task, while still capturing all those complex problem-solving pathways that it took to get there.
But here's the catch. Simply passing a test is not enough. Sometimes an AI will pass a test by just hard-coding a response, bypassing an existing mechanism, or literally tampering with the test itself. To counter this, the system ruthlessly filters out bad shortcuts. It scores the AI on some very rigorous dimensions. Things like, did it explore efficiently? Was the patch minimal? Was it actually honest in its methodology? By filtering for these specific traits, they are enforcing true engineering discipline, rather than just test-passing brute force.
And to stop the AI from just memorizing a fixed format or a specific sandbox structure, the developers intentionally make life super difficult for it. They randomize tool names, argument conventions, and output formats. They even inject realistic execution anomalies. We're talking transient command failures, missing dependencies, or really noisy, truncated logs. This forces the model to learn harness invariant problem-solving strategies. It essentially learns to actually diagnose and recover from errors instead of just throwing its hands up at the first sign of an anomaly. Moving right along to Section 3, Mastering Real-World Tools. We all know real systems are incredibly hard to access at scale, and pure LLM simulations, well, they tend to hallucinate pretty badly. So the researchers built Quai-Claw-Env, which is this elegant three-layer architecture that acts as a scalable factory. First up, the service layer constructs reliable, executable capability units. Next, the task layer combines these to generate diverse tasks with controllable difficulty, adjusting the toolchain length and complexity. And finally, the eval layer applies strict filtering. This whole setup ensures the AI can practice complex, multi-step reasoning across a massive diversity of tools and workflows, without the data quality ever degrading. All right, let's look at the payoff in Section 4, Benchmark-Breaking Results. The results of this infrastructure-first approach are honestly phenomenal. Across 6 different software engineering and agentic benchmarks, KAT Coder V2.5 stands toe-to-toe with the absolute giants in the field. On repository-level software engineering benchmarks, like SWE Bench Pro, it ranks second only to the massive Frontier Opus 4.8 model, heavily outperforming basically all other models in its class. But the absolute standout here is its performance on PinchBench, which is a major benchmark for agentic tool use. Get this, KD Coder V2.5 achieves a staggering score of 94.9, securing the absolute top result. I mean, this is undeniable proof that verifiable, robust training environments produce vastly superior AI. It's just a game changer. So, as we wrap up this explainer, I really want to leave you with this final thought. By truly mastering verifiable environments and rigorous process filtering, KT Coder V2.5 has removed one of the biggest roadblocks in AI development. If we are actually no longer bottlenecked by human oversight for verification and task creation, just how quickly will autonomous coding agents evolve next? Think about it. Thanks for learning with me today, and I'll catch you on the next one.